Today is the March 2002 GoldSim webinar, and we will be talking about doing spline interpolations of time-based data in a GoldSim model. Today, more specifically, I'll be talking about doing this with time series elements and also data vectors. There's also another way to enter data into a model, and that is with a lookup table. The concepts are similar, so I will just focus on time series and data vectors for this presentation. And I will start with time series. Before we get into spline interpolation, I want to talk a little bit about the interpolation that comes with the time series element and dealing with or how to deal with time series and represent the data in a way that works for your application. Okay, so in this model that we're looking at right now, I'm just going to scroll down. I have a couple of example time series elements here, and these two time series elements contain the same data. Let me open up one of them. This one's called evap interp ts, meaning evaporation. It's data that represents evaporation rates in millimeters per day. And if I click on edit data, then you see here we have date, time information on the left, and you can see they are incrementing by months. And then we have the values in millimeters per day here, and it is going from 2019 all the way through to the 1st of 2021. So 2 years of data that is in a monthly time steps. Okay, this other table is exactly the same thing, but they are just interpreted differently. And we do that, going back into the properties of this element, we do that with this drop list input here called represents in the data definition. And the default for all time series elements is instantaneous value interpolated. So I will talk about how that's represented in the model in just a second, but let me go to the other table, the other lookup table. This one is exactly the same data, but it is set to be represents with constant value over next time interval. Okay, let's also look at the simulation settings for this model. Open this, you'll see it starts with exactly the same start and end time of the time series, January 1, 2019 to January 1, 2021. Just a quick note, I do see a lot of people going to 12/31, 2020, something like this, saying this is 2 years, but this is 1 day short of 2 years. So just as a reminder, it's in order to get the full year, all of the days of the year, you need to go all the way, increment it all the way to the next year, but it's midnight of the next year, which actually does not simulate into that year. It just goes up to the end of 2020 because it's midnight. So keep that in mind. Also, if I were to extend the simulation one more day into the next year, then we would get an error. We would expect to see an error during the run of the model, because for this time series, the data extends only to January 1, 2021, and does not have data for January 2nd. And because the data represents instantaneous values that are interpolated, GoldSim has no idea what to say the next day will be in this time series. However, in this other time series that is set up as constant value over next, it turns out that because it is assuming constant values over the next time interval, then we could run a simulation for a longer duration beyond January 1st because it's holding this value constant. So just keep that in mind. The error that you the error message that you see when you run a model looks like this. And it tells you in here the time that the error occurs, and then it also tells you what element is having a problem with this. And it turns out there are actually two time series. There's the time series up above that's having a problem with this because it is also instantaneous and interpolated. And it says the last data point must be on or after the simulation end time. So what this means is we ran out of data essentially, and we don't know what to use for the time step that you're going toward there. And so what we need to do is go back. Okay, so we'll just run it to January 1. All right, so now let's look at the difference. Now that I've run the model, let's look at the difference in the way that GoldSim interprets these two time series. The other thing that I don't think I really mentioned is that currently we're running a model with calendar months as time steps. So every calendar month, at the beginning of each month, it will report a time history output. And I probably should show a little bit more about this. Let me go back to edit mode. So in the simulation settings, we can see when GoldSim will save time history results. If you click on this button up here at the top of the simulation settings called Show Scheduled Updates, and you see here it tells you exactly when it's going to be saving time history results, and it is on each month at the beginning of each month. And that's what the H means here. It tells you in a legend up here what those letters mean. Okay, so it's always good to just fully understand what GoldSim is trying to save when you're running a model, especially a very large model. That's why we try to show you these things. We also show information down here at the bottom. Sometimes instead of a blue circle with an eye, you might see a yellow triangle with kind of a warning down here to say, hey, you're saving a lot of information. Are you sure you want to do that? So just some things to be aware of. But we are running on a basic time step of calendar months. So that's important to note here when we're dealing with these time series. When I run the model now and look at this history, it's going to show me the value of both of these time series. You see here, it's only showing one line because the two lines are on top of each other. They are showing exactly the same thing. It does not matter if it's interpolated or constant over next because we have because the time step of the simulation equals the time step of the data set. So if I click in the table view, you can see we have exactly the same number of time points in this table and exactly the same values that are represented in the tables themselves. Okay, so there's nothing amazing here, but the whole point of this presentation is to talk about, well, what happens when your time step is smaller than the increments of time in your time series. So let's look at that now. Let's go back to the simulation settings and let's change it from calendar months to days. So now calendar months, days. Now we run the model. Look at this history again. And what we see now is a very different output depending on the way that the time series is represented. So the red line is showing us instantaneous interpolated values. And so what you see here is that between the beginnings of each month, it's just doing a simple linear interpolation between those months. And if we look at the table view, you can see the comparison here. When you're using instantaneous interpolated, just gonna make that a little bit wider, instantaneous interpolated, you can see that the input value only occurs at the beginning of each month. And then for each of the days within the month, it just does a linear interpolation in between until we get to the beginning of the next month. Whereas the constant over next, as you can see, is just holding it constant. Okay, so this all should be fairly straightforward, but it should be noted here, the impact of choosing that type of represents input on the time series. going forward if you were to have smaller time steps. Obviously, if we were to use these inputs as a driver in your model, you would have probably pretty significantly different results, right? Because because of the way that it is interpolating, you will have a shift essentially to the left for the instantaneous interpolated option. And so, for example, if you were to accumulate or integrate these values, you would get great or take averages for each of the month, then you would get vastly different numbers. And we can check that pretty easily, pretty quickly by using reporting periods in GoldSim. So those of you that don't use reporting periods, let me just show you that. Go back to the simulation settings, go down here to reporting steps, and let's go ahead and just add monthly reporting steps. And I'm going to give this a different label. I like to make the label represent the period that we have selected. When you do pick the, when you do select reporting steps, that you may want to change the way that the results are saved. By default, when you choose a reporting period, then the save results automatically defaults to only saving reporting steps. And we can check that up here in the show scheduled updates here. If I expand this a little bit, you see that it's still, the GoldSim is still updating on the daily basis because we have daily time steps. However, you don't see anymore the H symbol along all of those days because it is not saving time history results during those days. If I scroll down, you see it is only saving the values at the beginning of each month. So it's saving monthly values. You can see I scroll down, it's just, that's all it's saving. Okay. So if you wanted to save both the reporting values and daily values, then we would drop this down and select reporting and basic step. And then just save every, we want to save every 1 day. So I'll just change that to 1. Click OK. Now what I can do is, in addition to this regular time history result, I can create a new time history result that's a copy of it. And then let's just change this to be called period histories or period history. And then when I do that, now I can make use of reporting periods, which is very handy in GoldSim because it allows you to quickly do some period statistics on the fly without having to add any new functionality into your model yourself. GoldSim can do the work for you. So I can change the simulation time here to reporting periods. And now what I can do is I can say, well, let me just look at the cumulative over the periods. And as soon as I check that, that will cause different units. These time series represent rates, which is in length per time. Because I've selected cumulative, it says, oh, I can't use that unit anymore. I'm going to go ahead and go to a different y-axis and then make my own unit, which turns out to be millimeters day over day, which just cancels out to be millimeters, right? But we don't need to show that on the Y2, so I'm just moving that over here and changing this to millimeters. Okay, so now we can see what the period histories are in a cumulative basis to see how these two time series are represented on a monthly basis. And what you see is, like I said, a vastly different output depending on how it's represented. Sometimes it helps to view these types of period history results in more of a stair-step line. So I can change that here because these values are really only represented on months. So it might make more sense to show it this way. But the point is, the values are vastly different. Over the longer term, the totals might come out very similar, but on a monthly basis, they're vastly different because of how we're doing the interpolation. So I just wanted you to be aware of these types of issues. Another thing that might happen, let's say that we let's say we have a model that you, for other reasons throughout your model, you have inserted time steps. Let's say you have some reservoirs that are hitting their bounds, or maybe you have random events occurring, and GoldSim is inserting time steps. And let's say that you generally want to have a 1 month time step. So I'm changing this back to 1 month. So I have a 1 month time step, but we have random events occurring in the model between the months. So I'm just going to delete this period history result. We're not using that anymore. But we're back to a 1 month time step. And then now I want to add some random events. So I'll do that with a timed event. By the way, sometimes it's useful to add things like this into your model just to see how your model performs when random events are occurring. And it's a good way to see if your model is robust enough to be immune to random events occurring, because it should be able to produce very similar results whether or not you have random events occurring. If you get vastly different results when you have unscheduled events occurring, then you should consider revising how data is represented and how you're representing certain types of functions in your model that might be a function of the time step length, things like that. It would be useful. If you ever have questions about this, you can always contact support about it, but I'm just going to show basically what we might see if we have just a few. I'm just going to scatter a few random events throughout time, and you see that it's showing random time intervals. So on average, this element will insert new time steps on average once a month, but they're random in time. So it's not exactly once a month. They're random in time. Okay, so with that being done, we won't actually see this impact unless we view high resolution time history results in our charts. So in order to see the impact of inserted events, we go to Simulation Settings, and then we go over here to Advanced, check the box for Include Unscheduled Updates, and now we can see what happens when we have these random events occurring. And now I open up this chart, and you can see something strange going on here. This is due to the different ways in which we are representing the time series once again. So the constant value over next will hold its value until the next update occurs, and they're random. And so that's why we're seeing this kind of strange stair-stepping. And so again, it's important to see this because it's very common to have unscheduled events in your model. And so it becomes important how you interpolate between these time values when you're inserting events that are smaller than the time interval of your data set. Okay, so anyway, I just wanted to show you that so you can see the impact of these different ways of representing the data. Okay, I'm just going back to where we were, changing the time step, the basic time step to day. Okay, everything's back to normal. All right, so that's all I wanted to say about that. I didn't want to spend too much time on that, but you can see there are different ways of representing the time series. Okay, so here's another time series that is actually cumulative evaporation amounts. And let me open up that table. The reason I want to show cumulative is because sometimes this is a useful way of representing time series data. If I go to the edit data, you'll see here, these values are cumulative over time. They actually represent the exact same information that we were looking at before, but they are simply inputted as cumulative amounts. The nice thing about a GoldSim time series is it has this advanced option to enable the rate of change output. So the rate of change of these values over each increment for the duration of time that it's over during or that it crosses over between each of these time points. So these are each 1 day, or no, sorry, 1 month intervals. And so GoldSim will automatically calculate the rate as this integrated amount increases over that time difference for you. And then it puts that on another output called a secondary output of the time series. If I click on the output port of the time series, then you see the main output is the cumulative evaporation, but the secondary output that we have now added to this time series is called rate of change. So this makes it, it's a very nice way of inputting rates into your model without having to worry about perhaps what duration of time that you're trying to deal with. A lot of times people have monthly data, right? And so the tendency is to say, oh, it's going to be in millimeters per month, right? So they might make the mistake of saying, oh, my unit is millimeters per month. That's millimeters per MON. And this is a dangerous way to define a unit. MON is a constant, and it means 30.4375 days as a constant. So you'll get some errors in, for example, in February versus January, because both of those months don't have 30.4 days in them, right? So you'll get some errors there. So if you don't want to deal with anything like that, just get obtain your monthly data as a cumulative over time, and then you can just let GoldSim handle the rate of change, and it will calculate it correctly for you as a rate of change. So that's what's being done here. Anyway, the point is that this model uses an external function that has been compiled into a DLL that is separate from this GoldSim model, but it needs to be in the same directory. Well, it needs to be searchable and it needs to be found by this external element. And so you need to have both. You need to have the GoldSim model and this DLL. And so we've already compiled this DLL. It's all ready to go, and it just takes some inputs from GoldSim, and then when you run the model, it produces some outputs that then we can view, or we can access in other elements in the model. So let's just take a look at this interface. If I open up this external element, it's called Spline Interpolation, and we refer to this DLL that I told you about. It's just a compiled DLL here. If I went to File Explorer, you'd find it in the same directory as the model file itself. So we refer to that. There's a function within the DLL with this name. And then if we go over here to the interface of the DLL element, or the external element, then you'll see there are 3 input parameters, input arguments, that we need to provide. The first one is the definition of the time series. If you've never referred to the definition, it's important that you understand what that is. The definition means the entire set of data of the time series. Usually when you're working with a time series in GoldSim, it's just going to report to you or output its value at whatever time during the simulation, just the number that it happens to find at the simulation time that corresponds to the time row in the time series. So just one output at a time, for example, in a scalar time series, it's just going to report one value if you refer to the time series as you walk through time. However, when you refer to the time series with a dot definition, that is again a secondary output, and it refers to the entire set of the time series. So we're essentially throwing the entire time series out to this DLL all at once, the entire thing. So it goes out there to the DLL. The DLL walks through this time series and does calculations and figures out the spline interpolation, and then reports that back. But it does it one point at a time. You can see on the output side down here that it just reports one value, and it does that one time step at a time. That's just the way that this DLL in this case has been defined. The next argument is really just to ensure that it updates correctly. You don't even need to worry about this other argument. And then the third one is for when we have, if you happen to have a few missing values in your time series, it's not recommended that you allow many missing values in your time series, because a spline interpolation won't work very well. If you have many missing values, you should fix your data set before bringing it into GoldSim. But if you have a few here and there, and you want to mark them with a code, in this case -999, then the spline interpolation will just walk through those and do a basic spline interpolation over those areas where you're missing information. And I'll show you how that works in a second. But anyway, when we run this model with a 1-day time step, then what we see here is the spline interpolation. Okay, so this was the whole point of the presentation, was to show you this. But the nice thing about this is that, for example, when you look at a rising slope, we don't have a shift to the left or the right. Also, when we change slope from going positive to negative, that the curve will rise slightly above and come back down to allow you to better represent the values over a month. So if we were to integrate the spline output on a monthly basis to calculate monthly totals, we're going to get very similar results to the constant values. And we know that because we check it right here with an integrator, and then we calculate the difference between the input monthly values versus the output, and we see that the difference is very small here. You can see that number is very, very small. So that's the nice thing about the spline interpolation, is it provides a smooth curve that might better represent what you're trying to say on a smaller time step. Now, let me show you the same model, but with some missing, well, it's got different data, but it also has some missing values. So if I were to look at this time series and we scroll down, you'll see there are some points where we have some negative 999s, meaning there's some missing data. So in this particular case, when we run it, we look at the results, then you'll see where these missing values are. The spline will just take over and produce some interpolated values. Let me zoom into a place where we don't have very many missing values, just to see what that looks like. So I'm just holding the control key on my keyboard and drawing this rectangle to see what happens here. And you can see, because we have daily time steps, and I've zoomed in quite far, it doesn't really look like a smooth curve, but it would be if we increased our numbers of time steps. But you can see it produces what seems to be a fairly reasonable interpolation between these 2 points, holding on to the slope previous, and then also toward the end there. The spline interpolation does require, this is why we have to input the entire time series definition into this function, because it needs to take into account the surrounding data in order to calculate this interpolated section here. But if you have too many unknown points, oh, by the way, if I zoom all the way out, it shows you all the way down to -999. So let me just change the axis back with a minimum of 0. Okay, so if we go over to a point where we have a lot of missing data, then you can see it might start to get a little bit unrealistic here. So you should be careful if you're using this with a lot of missing values, because you might get something that starts to get a little bit ridiculous here. And you can imagine if I took even more points out, then this curve would get larger and larger, become much more strange there. So we definitely want to be careful about when we're using this spline interpolation with missing information. Okay, so enough about the time series. Let's talk about data vectors, because data vectors are also a very important way to represent time-based input data that might be on a larger time scale than your time steps of the model. The reason I want to talk about data vectors is because sometimes you want to represent monthly values that are 2 things. One, they repeat on some sort of interval, and in the simple cases that I'm showing you today, it's always monthly. But you could have other types of intervals. You could have a diurnal pattern, for example, where you have 24 values that represents something that occurs every day over a 24-hour period. They fluctuate through the day, but they repeat every day. And you may have a 1-hour time step and it runs for a long period of time, or you might have a smaller time step, maybe a 1-minute time step, with 24-hour input data points that's repeating. A lookup table or a data vector can easily handle that type of thing. For this presentation, I'm always just showing you monthly values with a smaller time step, such as a 1-day time step. In this case, we have 12 monthly values. We can represent those in a data element. Like I said, you could also represent this in a lookup table, but I'm using a data element because I want to show you another thing about this. But consider them quite similar, except obviously a lookup table provides a lot more flexibility on how you interpolate. But you can see examples about lookup tables if you go up here to File, Open Example, and then go to our lookup table examples that come with GoldSim. There's lots of resources there for learning about lookup tables. But let's say I have this data element here, and it's a vector of months. If I click on Edit Data, you see it has these different values here for all of the months. So what we can do is we can write an expression that refers to, and these are, I think, units of kilograms. We can refer to that table or that data element, that data vector, with an index of month. So month is a run property of GoldSim. And when we do that, when we refer to this data vector with an index of month in brackets like that, then as the month changes, it will then look up a different value in that table. So when I run this model, then I will see values like this. And we can compare this time history to the final value chart of the data itself. If I right-click here, select Final Value Result, it shows me these values. And then you can compare that to the time history. We should get the same thing, the same values there. So here's the time history, same thing. It's just walking through time. So that's how we would refer to each value there in this data set. But it turns out that if you have a 1-day time step, which is what we have, that perhaps you want to interpolate once again between those values. So that's what I want to talk about now. But I also wanted to mention that sometimes the reason we want to use a vector of points like this is perhaps we are calculating them on the fly. Perhaps the model is generating 12 values for you. Instead of you inputting them, it might be generating them. So imagine that you have an output of your model that produces a vector. In my case, I've just written a very simple equation here, but it does output a vector. So once again, if I run this model, then if I right-click here and go to Final Values, you see it shows the same. It just happens to be the same values here, but this is generated when we run the model. And so this is somewhat common where you generate these numbers and then you want to use this information to walk forward through time in your model. But it could be either way. I just wanted to show this as one option of generating a vector. It could be that you just enter the values statically, or they are generated by the model. One thing to keep in mind, however, is that if the model is calculating your vector, that this is something that would have to be done, obviously, prior to you using the information. So perhaps this information is coming from a subroutine, right, or what we'd call a submodel in GoldSim, or some other way of producing it. But the values need to be available before you refer to them. But they could also be updating, right? So these values could be changing through time as well. So there's a lot of flexibility in GoldSim, as you can see, and we could go on for a long time about all the different ways of representing data. But the point I want to make here is that we have these monthly values and we may want to interpolate between them. And so once again, I will show you the difference between ways of interpolating on this kind of data. So in this first expression here, we are just using the month run property again to refer to each of the monthly values. So I'm just going to call this, no interpolation here. And then we have another expression down here in which we are doing interpolation. How do we do an interpolation on a data vector? Because the month output, it only changes on a monthly basis. The month output, and it might help if you see the output of the month. So let me just do that. Month, I'll just call this month output. And then I'll just refer to month. And if you're wondering where this run property comes from, you can always come over here to the browser and right-click and select Show Element Subitems. That's also up here in the View menu, and go to Show Element Subitems. Either way, when you select that, you'll see this folder appear. You can open it. It's called Local Properties here. It's Local Properties or Run Properties, the two ways of calling them. But you'll look into this folder called Calendar Time and find month. So that's what we're referring to. All of these run properties are available to you globally in your model. Okay, so let's take a look at, let's see what month looks like when we run the model. Okay, so you can see that by the way, this is still a 1 day time step, so you can see it's holding constant the value of month, and it just increments during the course of the year, 12 times, 12 of these values. Okay, so that's all fine, but what if we want to interpolate? Well, we could write an expression. In this case, I called it decimal month, and this expression is, when I open that, you'll see it's just a calculation I did where it's the month plus the days of the month. These are all run properties, by the way, everything here. Month plus the days of the month divided by the days in the month. And I also said day of month minus 1 here, so that we start at 0 when we are on the first day of the month, and then it progressively increases toward the final number of days of the month until it becomes closer and closer to 1, and until it increments to the next month. So this is a way to produce a fractional month output in which we can use to interpolate on the data vector. So if we were to plot both of the month and the decimal month together, then you should expect to see one. Let's see, so if I say month output and then decimal month, run the two, and you can see that's the difference. So by creating a decimal month, then that allows us to do an interpolation on these monthly values. So I'll call this interpolated values. And when we run this model, we look at the interpolated values, and then we can compare it to the monthly values. It's the one that's called no interpolation. There we go. This is very similar to what we saw with the time series, right? Everything is kind of shifted over. So if this is acceptable, then that would work fine to do that kind of interpolation. And let me just show you how the interpolation is done. If we go to the interpolated values expression, you see we're using this built-in function in GoldSim called vinterp, and then you refer to the table, and then you refer to the index. In our case, it's the decimal month, and it will do an interpolation. So that could work fine, but again, we have this shift. And so this is a case, again, where we might want to consider using the spline interpolation. So let me open that one. By the way, these models, I will provide them along with the recording of this presentation in our webinar archive. So here's a model, and this, I'm going to delete some things. This was from previously there. Okay, so here's a model where we have, once again, some monthly values. And we just use a spline interpolation to interpolate those with a smaller time step. And, oh, I'm running this for a long period. We don't need to run it for that long. So let me just change the simulation settings to run from 2019 to 2021. Nope, not 2001, 2021. There we go. So we'll run it for 2 years. There we go. So we've got multiple lines here, the spline interpolated versus the monthly values, as you can see. And then we also have on top of that the cumulative of both of those, just to show that we're getting the same cumulative amounts over the course of these 2 years using either approach. But the spline interpolation, I wanted to show it for multiple years just to show that you can have repeating 12 values and also interpolate just fine through all of that. So we could continue this for as many years as we want. So the only thing with this is that this is a little bit different implementation. This uses a script element instead of a DLL for doing the interpolation on a data vector, just because it's a little bit simpler than the time series. So if you go to the script element, you will see here's the code to do the spline interpolation there. It doesn't use any external functions. But it is important to note also that this particular model is set up for going from a monthly data set to some smaller time step. It doesn't have to be daily, but it has to be a smaller time step than 1 month. Well, it would still run with a 1 month time step, but the point is it's assuming that you have 12 monthly values. If you wanted to change this to something other than 12 monthly values, then you would also need to change these 2 input parameters, I and T. Just keep that in mind. But it should still work fine as long as you put the correct I and T parameters that are a function of whatever your time step of your data is. It should still work the same. The other thing that you need to keep in mind with this approach is that it requires that the data coming in is unitless. So you got to be kind of careful. Typically we kind of take it for granted if you've used GoldSim for a long time that it always takes care of units for you. But in this particular case, because the calculations are being done in unitless, it means we need to cast off the units. So if we go to the input side here, you can see we are casting them off using this vertical line character at the end of the reference to the input with the unit that we want to cast off. So that means the values going into this function are going to be in terms of cubic meters per day, but unitless. So that means we have to be careful about how we add units on the output side. They need to be the same, right? Or otherwise you're going to have an error. Not an error, but you'll have misrepresented the information. So it's important on the output side that you add exactly the same units back on when you come out the other side there. So those are the things to be careful about when you're using this model. But this could be very useful for when you're trying to deal with a data vector. And again, this data vector does not have to be input, a static input, right? This can be an output of something else going on to create this vector that you're going to be interpolating on, which is nice, could be nice there to have. So let's now talk about an application with the last little bit of time I have. So here is an application. It was just one I thought of. There's obviously many applications to this, but I wanted to show how doing a spline interpolation versus not doing one can vastly impact the output of your model. And so in this case, and I'm using scenarios to compare with and without spline interpolation. So let's first just let's just look at not using spline interpolation. So I'm clicking on my scenario, active scenario selector down here in the bottom status bar of GoldSim. Another way to do that is go to the scenario manager and come down here to active scenario drop list and pick the scenario you want to run. In my case, I want to look at monthly average, not spline interpolation. But you can also see it selected down here. So when I run this model, we're not doing any spline interpolating or anything like that. But what we have here is a pond or a reservoir. And I'm going to expand. We have in this case, a pond. The volume of water in this pond is represented by the blue line. And you can see here, it's running for 2 years, 2 calendar years. We have some random inflow coming in. That's shown in red. As the inflows come in, the water volume rises. And then later in the year, the inflows decrease. We also have a discharge rate, so we're removing water from this pond, and that is shown in the green line. And then we have a dashed line, and that's the important part. The dashed line is what I'm calling an operating target. Maybe there are other names for it. It's a target we use to try to control the volume of water in this reservoir. Sometimes with a pond, sometimes you just want to maintain a constant water level through time. So it'd be much simpler to just be one line going straight across. But sometimes they're changing. Sometimes the targets are changing. Sometimes you want to cause the pond or volume of the reservoir or pond to change over time in order to anticipate or manage floods or provide a certain amount of water at certain times of the year, more over other times. There are lots of reasons for doing it, but as you can see, we have a target that is stair-stepping, and that's a problem. The stair-stepping target causes issues, and let's take a look at that. If I zoom in, particularly on the outflows end of the curve, just zoom into this here, you can see what's happening here is that as the target drops with these sudden stair steps, it's telling GoldSim, hey, we need to drop the water volume accordingly. And when it does that, it says, well, we're suddenly way above the target for a little while, and it tells the model to discharge a high rate of outflow. And so you get these spikes every time we have this stair step drop. So anytime in a model where you have a comparison to some sort of target like this, and you're doing stair steps because you have the data coming in with a larger time scale than your time step, you will have situations like this that causes an unrealistic output in your model. And this can have impacts throughout, right? Because this discharge might go into other places in your model, and you have these weird spikes that really would not be happening in the real world. And so we need to be careful of that kind of thing. And this would be a perfect example of where we'd want to do some sort of interpolation. A linear interpolation would be much better than this, but maybe we don't want a linear interpolation because that, once again, like I was saying, it shifts everything to the left, right? In the cases that we have here. Well, it could be argued also, by the way, that, well, why not just provide daily time step information for this curve? Yeah, you could certainly do that, no problem. You could just calculate those and put those into the model. But like I was saying, sometimes those values are calculated in GoldSim, right? So it's much easier to calculate 12 values instead of 365 values, right? So let's take a look at the difference between doing the spline interpolation and no interpolation. So I'm going up here to the scenario manager, and instead of running just one of these scenarios, I'll run all of them. Okay, we just ran all the scenarios. Going back to the same chart, and now by default it's just showing us the inflow for both scenarios. Well, they're the same for both scenarios. The inflow does not change. If we look at the volume of water in the pond, you see that we have these stair-stepping results from not interpolating, versus the smooth line of interpolating. If I look at the operating target, well, that's what we were seeing before. We have the spline interpolated versus the constants, but the impact is most obvious on the discharge rate, where if I zoom in on the discharge side, we have these spikes that are no longer occurring. Another way to look at it is all scenarios, all results. But before I go there, let's just look at the spline interpolated. You can see it's got this nice, smooth target line that's changing over time. And then our response can be smooth as well, which is nice. We can also do a comparison of all scenarios, all data. I realize this is a lot of information to look at, but when you zoom in to certain points in the model, it might be quite useful to see how, well, okay, that's not very useful. Let me reset the scale. Let me go to one of these over here. Okay, so you can see here where scenario 1, the not interpolated, is a solid line. Scenario 2, the interpolated scenario, is the dashed. So anything that's dashed is the interpolated scenario. And you can just see here that instead of doing a step, our target and our volume, we have a nice smooth curve. Therefore, we do not show these large spikes. So this is just one example in which it could be useful to smooth out your input data in order to provide a better response of your model, which could be impacting other places in the model significantly. So with that, hopefully that provides you some good background on how to use the spline interpolation functions that we have in these example models, and when to use them, and why we want to use them. So there are lots of other examples that we could show that it would be useful to do this type of interpolation. But anyway, that concludes the presentation, and I appreciate everybody joining today. I hope this is useful, and also, again, like usual, I hope you come back to our webinar for next month, and I will take some time now to answer any questions that you might have. Otherwise, thanks again, and have a great Thursday. Okay, somebody asked, how do you pull in the DLL for the spline interface? Okay, so if you're new to using a DLL, the best way to learn how to use these or get that kind of information would be probably to go to our example models. And so what you do is you just start up GoldSim, go up here to File, Open Example, and then go to General Examples. It will, when you go there, it'll automatically open this File Explorer to this place. And then you'll see an external folder. Go in there and open this model and start looking through this model. We do have examples in our library as well that are quite simple, but I highly recommend that you start here. Start at the very simplest level to get an understanding of how these work. Also, you can always click on the Help button of GoldSim, and you can simply just go over here to search and then go to DLLs and look that up. But in the case of the models that I've been presenting, the way that it's done, go back to edit mode, the way that it's done is through what's called an external element, and that is in the functions category here called external. And the way that you pull in the DLL, or the way that you interface with the DLL, is you simply put in the path to the DLL here. And then you need to refer to the function that is exposed on that DLL here. But again, you need to follow the rules of how to interface with a DLL, and you need to have some background in writing and compiling a DLL. And so that's why I was mentioning the best way is to go all the way back to the basics. Look at our very simple examples that we provide with GoldSim, and also our documentation on how to do that. But essentially what you will need to run this particular model is the model file and the DLL file as well, and then refer to it here like that. So I hope that answers your question. And somebody asked, is the vinterp function specific to GoldSim? Oh, yes. Okay, so that is a built-in function in GoldSim. And let me go to that model again. And that one was here. Here it is. Okay, so in any expression, it doesn't matter. I'm just doing it. I happen to be using an expression element, but you can do this in any expression input field, any equation input field in any element in GoldSim by simply right-click and go to Functions. And here are all of our built-in functions in GoldSim. It turns out that we have a whole bunch of array functions. That's where the vinterp function is located. So you go to array operators and you'll find there is a vector interpolation, vinterp. There it is. And you can look it up in our documentation to see how it's used. But essentially it requires two arguments. The first argument is the name of the vector. It has to be a vector. The second argument is whatever the index is that you're trying to use to look up the value that might be between points and do the linear interpolation between those points. So that's where we get the function from. I hope that answers your question. And the question, follow-up question, it only does linear interpolation? The answer is yes. It only does linear interpolation. That is correct. Yep. Yep, you're welcome. Since there are no other questions, I will go ahead and close this, end this webinar. Thanks again for joining, and we hope to see you next month.